Welcome. Let's discuss the idea of partial fraction decomposition. So let's say that we are being given this rational and we want to rewrite it in a different way. Well, let's talk about the process to do this. First thing that we're going to do, we're going to take a look at the denominator of the fraction and we're going to factor that out. So let's rewrite the numerator and the denominator. Let's look for two numbers that if we multiply, it gives us positive 20. And when we add them up, it gives us positive 9. Well, those two numbers are 4 and 5. 4 times 5, it definitely gives you 20. And 4 plus 5, it definitely gives us 9. So the denominator, we can just rewrite it as x plus 4 times x plus 5. And now that we have our denominator in factor form, now let's set up the objective. We are going to say, well, this fraction that we were given, I can see that the denominator, it was written as the multiplication of two expressions, x plus 4 and also x plus 5. Well, we can rewrite it as the summation of two other fractions. One having the denominator of the first expression that we factor out in the denominator, x plus 4, and the second having a denominator with the second expression of what we factor in the original problem, x plus 5. But now we have a problem because what will be the numerator that will make this true? Well, now that is our new objective. But there is a relationship that we are going to use. It will always be true that the numerator is always 1 degree lower than the denominator. So now let's take a look at each expression individually. On our first fraction, we have a denominator of degree 1. So therefore, the numerator of our first fraction should be of degree 0. In other words, it is just a number. It is a constant. There is no variables on it. Let me use a placeholder. Let me use the letter of capital A. And do not get confused. A is just a placeholder. It represents some number. Maybe it is 5. Maybe it is negative 2. Maybe it is 30. We do not know. But I know that it's a number. So let me use it as a placeholder. In our second fraction, we also have a denominator of degree 1. So using the same relationship, the numerator should be of degree 0. Let me use a different placeholder. Let me use the letter of capital B. Maybe B it is equals to 1. Maybe B it is equals to negative 5. Or maybe it is equals to negative 3. We do not know the value of it, but I know that this will represent some number, which we're going to find out next. So now let's talk about how we can find the value of the numerators, which in this case, we only have A and B. So this is going to take some calculation. So let me erase what I have written in strategy to give myself some space for this calculation. But this is what the rest of our process is going to concentrate, finding the value of that A and B. So how about we start by trying to eliminate these fractions? Well, one way of doing it is by looking at the whole denominator of the initial expression, x plus 4 times x plus 5. Let's multiply this expression on the left and the right-hand side of the equation. Notice what will happen. When we multiply it on the left-hand side, the expression of x plus 4 is going to cancel out with x plus 4, and the expression of x plus 5 is going to cancel out with x plus 5. So on the left-hand side, we only have the numerator of the original problem. And on the right-hand side, when I take a look at this expression and I distribute to the first term, only x plus 4 is going to cancel out. And what's going to be left, it is the numerator, which is a, multiplied by the expression that is left, which is x plus 5. And when we distribute to the second term in the right-hand side, the expression of x plus 5 is going to get canceled out with the expression of x plus 5. So the only thing that we have left to multiply it is the numerator, which is b, times the expression of x plus 4. So by multiplying by the denominator on both sides, we are making our problem more manageable because we do not have any fractions anymore, and that's going to make the process more simple. So now let's expand our result. The left-hand side, let me just bring that down. On the right-hand side, let me start by distributing that a, which is going to give me a times x. And let me distribute to the second term, so that's just going to give me 5a. Plus, let me distribute the placeholder of b, so we're going to get bx. And let me distribute the placeholder of b, which is going to give me 4b. Let's not get lost in our calculation. Let's pause and let's think about what we're doing. The objective right now is try to figure out what is the value of a and b, which we can find in these locations in our calculation. Let's organize our results, and let's do it by grouping terms using variables. The left-hand side, let me just bring that down. When I take a look at all the different terms in the right-hand side, I can see that there are two terms that has the variable of x, ax and bx. So how about I rewrite this as a group? We're going to get the first term as a coefficient of a plus b. And one thing that they have in common, it is the variable of x. Now be mindful that we are just rewriting the term, because if we would distribute the x, we're going to obtain ax. And if we distribute it to b, we're going to get bx. So we're not changing our problem, we're just grouping. And now these two terms that do not have a variable on it, let's just write them as a group as well. 5y and 4b. So now let's make sense of what we are doing here. When we are working with an equation, we want to make sure that the whole expression in the left, it is equal to the whole expression in the right. And one way to guarantee that that is happening is to make sure that the terms that have the same variables are equal to each other. In other words, 3x should be equal to a plus b times x. And the constant of 10 should be equal to the constant that we have in the right-hand side. So 10 should be equal to 5a plus 4b. And we can use this relationship to form a system of equations. So let's just set the coefficients equals to each other. 3, let's set it equal to a plus b. The coefficient of the variable of x in the left should be equal to the coefficient of the variable of x in the right. And the constant in the left is going to be equal to the constant in the right. But now here you have different ways to solve for a and b, since it is a system of equations. I'm going to use the method of substitution. Let me just solve for one variable. On the equation in the left, let me just solve for b. So let me take a and move it to the right-hand side. So b is equals to 3 minus a. Let's just keep this expression in mind. So how about I use this expression and I substitute it on the equation in the right. Now everything is written in terms of the variable of a. We can solve for that. Let's distribute that 4. That's going to give us 12. Let's distribute that 4. That's going to give me negative 4a. The right-hand side, let me bring that down. Let me combine like terms. That's just going to give me 1a. So let's subtract 12 and get a value for a, which is negative 2. So now that we know the value of a, let's go back to the expression of b and substitute it there. So when we distribute, that's a plus. So we are done. We have found the value of those constants that were needed. A being equivalent to negative 2 and b being equivalent to positive 5. So let's go back to our setup and let's plug in those values. So let's recall that we have our setup here. We found out that A was -2 and B was +5. So let's substitute A for -2 and let's substitute B for +5. Well, we can rewrite this a little bit further. Instead of having a -2 on the top, let me just bring that negative to the front. So this is our result. So what we are saying is that this initial rational that we were given, we can definitely rewrite it using the expression of 2 divided by x plus 4, which it was one of the fractions in the denominator, plus 5 divided by x plus 5, which it was the second factor when we factor out the denominator. And this is what we define as partial fraction decomposition. Now let me convince you that these two expressions are equal to each other. Let's graph the original problem and let's graph our result. And let's see if we obtain the same graph. So let's start by graphing the original problem. 3x plus 10 divided by x squared plus 9x plus 20. And now let's graph the result that we found using partial fraction decomposition. Notice that we obtain the same graph. They are overlapping with each other. So we have found two equations that are equal to each other using the process of partial fraction decomposition. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.